In this video, we're going to practice computing the determinant of a 4 by 4 matrix. So I've written down a 4 by 4 matrix here that we want to get the determinant of. And when I look at this matrix, I see that the second column is kind of very inviting here because it has a couple zeros in it. And we know that if we can get a standard basis vector in a column, then we can reduce the dimension and make our life easier. So the first thing I'm going to want to do here is try and turn one of those ones into a 0. So what I might do is I might subtract the first row from the third row, which we know does not change the determinant. So let me write down the first, second, and fourth rows the same. And now we'll take negative of the first row added to the third row. So it's a -2 and a 0 and a -1. And a -6. Now we can't quite reduce the dimension here because we have our first basis vector in our second spot. But that's okay, we can swap the first two columns, and a column swap we know alters the determinant by a minus sign because it changes us from a right-handed coordinate system to a left-handed coordinate system, or vice versa. But we'll go ahead and swap those two columns. See, that's a -2 in the third spot and a +2 in the second spot, sorry. And then our third and fourth columns stay the same. All right, now that we have the first standard basis vector in the first column, we can reduce the dimension here. So this will be the same thing as, still have that negative sign out front, determinant of the 3 by 3 matrix 2, 4, 2, -2, -1, -6, 1, 3, 5. Now when I look at this, I notice that everything in the first row is divisible by 2, so we can go ahead and factor that out. So we have -2 times the determinant of 1, 2, 1, -2, -1, -6, 1, 3, 5. And at this point I'll mention that there's lots of different ways to compute the determinant of a 3 by 3 matrix. Feel free to use your favorite one. I'm going to use my favorite one, which is just continuing what we've been doing. Unfortunately, I don't see a whole bunch of zeros anywhere, but I do have a 1 up in the top left, and I can use that to make zeros below it. So in particular, let me copy down that top row of 1, 2, 1. If I add 2 times the top row to the second row, that'll make a 0 here. And we'll have a 3 and a -4. And if I subtract the top row from the third row, that'll give me a 0, and then a 1 and a 4. Now once again, we've got the first standard basis vector in the first spot. So we can reduce the dimension once more. We've got -2 times the determinant of a 2 by 2 matrix. And again, there's several different ways that we could compute this 2 by 2 determinant. I think what I usually do is simply take the product of the diagonal and subtract off the product of the anti-diagonal. In other words, we'll do 3 times 4, and we'll subtract off 1 times -4. We've got -2 times 12 plus 4. We've got -2 times 16. So our determinant of our matrix is -32. So again, there's lots of different routes you can take. This is just one particular way that we could do this one.